Hi guys, let's begin with the demonstration for our semantic web engineering project. So our project is titled Artwork, Semantic Cataloging and Cultural Analysis. This project focuses on making cultural heritage data more accessible and interconnected. So our problem definition addresses the problem of the fragmentation of cultural heritage data. Artwork metadata is often scattered across institution, making it difficult to retrieve and analyze effectively. So this artwork solves this problem by creating a unified framework that connects artwork with their cultural and historical narratives. So we have used two use cases in our project. The first use case is about dynamic artwork retrieval, which will enable users to apply filters like medium, year range to retrieve details about the artwork. The second use case is about exploring the historical periods. So this use case will be explained in detail later in this demonstration by one of my team member. So I will hand over to Ujjita. She will explain the data pre-processing and ontology design. Over to you, Ujjita. Thank you.
Thank you, Ritu. So now I'm going to be talking about data pre-processing. So in data pre-processing, we have used 8 of our data sets. We have processed data sets by using Python scripts by filtering and merging data. We've also removed the duplicates and handled missing values and made our data sets consistent for our use cases. Now later, moving on to the ontology. For our ontology creation and development, we have used a Protege tool, and we utilize CIDOC CRM, which is the top level ontology for art related semantic projects. And in addition to using this, we created classes, object properties, which are highlighted in bold, which are used for our use cases, data properties, and especially we also created SWRL rules. Um, these classes and properties are designed based on the columns we selected from the datasets. We also incorporated this SWRL rules in our ontology design. We also ran this RDF file with an validator to make sure our ontology is consistent. Now I will pass to my friend Dimant.
Yeah, thank you, Urjita. I will talk about like how we transformed our raw data into a dynamic knowledge graph using onto text refine and GraphDB. We first began by generating triples and onto text refine. After we uploaded our processed data sets, we carefully mapped this into our ontology. This included defining meaningful relationship between the different elements, such as linking an artwork to its title, house name, provenance, owner, and so on. Next, we after creating this, we took this triples into we exported these triples into TTL files. Later, we imported this TTL files into GraphDB, where GraphDB brought life into all these triples that we generated and helps us to run SparkQL queries on the knowledge graph that we created. Now I'll quickly talk about the two SparkQL queries that we are utilizing in our project. For use case one, this is a SparkQL query. This query is designed to dynamically fetch artwork details based on user-defined filter, which my friend will show in the UI demonstration. This query will help us retrieve specific artworks based on the user filters such as size, dimensions, etc. So coming to the use case two, it is also a dynamic query similar to user one, but what we do here is we retrieve artwork data based on date ranges based on periods, specific art periods that we let allow users input into select in the web app, which my friend will again show in the UI demonstration. Now I'll be handing it over to Pawan to continue with the further explanation of our project. Thank you.
Yeah, thank you, Diman. Let me just share my screen. Yeah. Here I'll be talking about the project setup how we set up the project, based on all the things that my peers and my teammates discussed. So firstly, when it comes to prerequisites, you need to have Python and you need to have any pre-installed Chocolatey remove. You need to install, we are using React.js and Flask for front-end and backend. So you need to have a React.js and Flask installed, run the npm required commands to make sure all those commands are installed. To get the front end running, go into the source folder, ArtTrack folder, and run npm install and npm start. That should start your front end. And to run to the backend, go to the backend folder, cd into the backend folder, and run these three commands. Open python app.py. That should link you to the backend. Depending on what inputs the user selects, will be given results. That's the entire project on. To host the GraphDB, what we have used is we use an Azure VM, Azure as a cloud provider, and we used an Azure virtual machine. One thing that to keep in mind while using the Azure VM is to open networks to all possible networks, so all possible IPs. So preferably add an inbound port rule for port 7200, and that should give you access across all other VMs to access the link that we'll be sharing in the documentation in the README. Now I hand over the call to Rachit to explain about how the project is being implemented and the demo.
Thank you, Bhavan. I'll just quickly share my screen and continue. Can you stop sharing? I'll just have to share. Yeah. So initially, once the VM is generated and created, so we need to install the GraphDB package there on the VM and run it there. So we have started the GraphDB package on the VM. Once that is done, we just come to our UI. Just give me a second. Yes. So we come to our UI and we go ahead with our first use case. So here we could select any number of museums in which our data set is present and the knowledge graph is mapped. And let's say we want to fetch data of some artwork that is having the medium marble, or it has something related to marble in its medium. So we can select any of the data sets that we want specific to the desire of the user. Let's say we can start for the year 1200. And the years here we have chosen such, I mean, I've given these inputs because for use case 2, there are some artworks which have the art periods mapped to them, which run to 1200 or 1500 and specific years like that. So let me just give 1900. And again, size range is an optional input. You can give anything, and then you will be able to see all the artworks that have the medium marble and these details such as title, culture, date created, museum, and their dimensions are displayed. Here you can see various results, and these are the other things that we can capture. And you can run around with anything. So the another important point I would like to tell is if you give no inputs and try to run the result, the UI prompts you to select at least something about the museum that you want to be displayed. And like I said, it is being hosted, the GraphDB is being hosted on cloud over here, which is this IP. And this will be shared in the README file with you. And similarly, now coming to our use case 2, which is about art through time, which talks about the various periods, and you can select whichever period you want. We have categorized the artworks present in our data set in these periods, that is Renaissance and Baroque, modern art, 20th century, and contemporary art. Let's say we want to go to modern art, and a period where it was called sub-period was realism, and then let's say impressionism. So our knowledge graph searches through the whole database and tries to fetch results for that. Again, we can see that different artworks which fall under this age within this date are fetched. And how we have modeled that in our code is in our the use case 2 in Flask. We have given mappings for every specific art period and the sub-art period, and that is being mapped to one of them. So let's say now if I want to again run it, I'll just reset everything. Once that is done, I'll just go to contemporary art, performance art. So it tries to look into the whole knowledge graph with the mappings that we have created and tries to fetch some result. If it doesn't find anything there, it just gives us a simple result that there's no output present. Now this is for impressionism, and again, I created this. Let's say we want to add these other filters that we want. So it takes some time for the queries to be run, because you can check that on the monitor in GraphDB. Right. So these are the updated results for that query. We can see there's no query running currently. So this is how we've integrated. We can, we can experiment with various types of combinations, whatever is needed. So we reset it and then we can select whatever we want. And these, all these sub-periods and periods of artworks was done in our literature review, which is given us a data about the artworks that we need to look out for. And based on our data sets, they are mapped. So this is the working of it. Like Pawan had told about our front end and back end. So you can see our back end, and we have used Flask Python to run our back end. The key important thing that I want to highlight here is the SparkQL endpoint. And this is right now having this IP because we've hosted our GraphDB on Azure. Initially, we tested out everything on our local host. So that time we had our local host IP here. So all the backend mapping and backend implementation and integration with UI is done. And for the front end, like Pawan said, we have implemented it using React.js. This has all the details in it. Yeah, so we would be submitting a README file with detailed documentation of how to run the project. Thank you, guys.
All right. Thanks, Rachit. So I would like to discuss the roles and responsibilities of each of my team member for this project. So the first part was about the data pre-processing, which was worked upon by each of the team member as our data set was very huge. And then ontology design was done by Urjita. Triple generation and mapping was done by Dhimant. Front end and back end was done by Rachit and myself. Pawan, Urjit, and Dhimant worked on hosting our GraphDB ontology. And lastly, everyone contributed in documenting our project. So that's all about our project. Thank you.